Okay, website. All right, here we go. All right, so first things we discussed was in the fifth hour said that this number should be between 0 and 1. This is a decreasing situation. Then we should take this in steps. Like we should know that this is asymptotic behavior. So we should know that there's an asymptote at y equals 2. So that means this sucker went up 2. So we have a plus 2 in the equation. So this is the breakdown of it. Now I told you the next thing, and actually when you are going to have to go, Ella, okay, the first thing you're going to have to do is graph, and I'm going to ask input, say it. The most important input point is the where did the 0 power rule coordinate go? So for the parent function, where did 0 comma 1 end up? And it's actually an easier question than you think when we don't deal with, saying this online mathematically, that there's no multiplier on the outside of this. And I don't like thinking about that when we do exponentials. But it's like the base being thing. That is where the 0, 1 point ended up. It is exactly one above the asymptote in this case because it is above the asymptote. So then that tells me that I went 1, 2 right, and then 2 up. Actually, it's this point is 0 comma 1 went 1, 2 right, and 2 up. So now my exponent has an x minus 2. I should have asked you that. That should have been, what would that be in the exponent then? Right 2 is minus 2. Okay? So that's what we got so far. This is worth like I'd probably make this a 3-point question. You got 2 out of 3 points just because you located that coordinate there. Now, what is the fraction? Now it's check some other points. I see that point and that point, but it's this one I want to focus on. In this one, I did guess with Victor that it was 1/2 because it's only one above and to the left, and then I questioned it. And then actually I made a mistake, but I looked at my coordinate plane wrong. Is that correct? Input, say it. I can check now. This is 1 comma. What I'm supposed to get is 1 comma 4. I'm sure there's a better way of doing this, but this was the thing that I just thought of. I accidentally thought this was 1 comma 3. I looked at the thing wrong, and that's why I got all jacked up with Victor. I'm like, wait a minute, something's wrong, and I just messed up. 1 minus 2 is negative 1. What's 1/2 to the negative first power, everybody? 2. What's 2 plus 2? 4. Check. I'm excited. If this works, then I'm really excited, and I know I have a very good equation, but I should be good right now. So the last one I checked was 0. 0 minus 2 is negative 2. 1/2 to the negative 2 is 2 to the 2 power. 2 squared is 4. 4 plus 2 is 6. So this one checks. 0 comma 6 checks. I know I'm good to go then. All right? And everything else should fall into place. So they're telling me it's exponential. They're telling me that we have some sort of transformational thing. This fits with those 3 coordinates. So that's how input, output helps you there. Okay, go ahead and turn in your homework, and then we're going to go bell working on this. And we're going to give various students to answer. And I guess we can do one at a time. And once I get the papers, we're just going to go for it. And we'll do one at a time and answer these questions. So you can get started by writing that down. And those will probably sit on my desk for a while. Got some other things I've been collecting. People randomly giving me late work, and people being good about making up tests, but still makeup tests are tough to keep track of. So,
I have that.
What do you have?
Like work.
I got more work I got to collect now. Okay, so greens.
Never gave me my
Because you never show up to class. Oh, here we go. When I pass those back, boom, shakalaka. Did you hear that? The internet. All right, here we go. It's right here, man. There you go. Switcheroo. All right. All right. Ella, you're first. Input, say it. And then what am I going to input first? What are we going to input for x first in your first equation? By the way, before you answer that question, I'll give you a minute to think about it. This book is really bad with their like typing in this chapter. This is the exponential chapter, so x is an exponent. It doesn't look like it, does it? They don't do a real good job with this. So when you're looking at your book, just assume that that is up there, and it should be written more like this. And we know that our test making software does the same thing, so we've adjusted over the years and made it really look exponential. But anyway, what do I input first, Stella? Starts with a Z, so we can get this moving. Okay, because I want to know the zero power. And even though that's 2 to the negative x, it's still 0 that I want to plug in, because negative 0 is still 0. All right, so what's 2 to the 0? 1 minus 2. No, you're right. It is 1, but what's 1 minus 2? All right, so that's our first point. And then we should put two things together here. Where's my asymptote looking at the transformations? So it's y equals negative 2 for the asymptote. So those two things coincide based right off of what I just told you on our last question. You know, the 0 comma 1 point, the 0 exponent power point is 1 above the asymptote. If there is no multiplier out in front of this thing, which I don't like doing that with these. I really don't. The book's obsessed with it. I don't know why. Student number 2, Jennifer, what other 2 points should I plug in? Absolutely. And actually, negative 1's easier than 1. So let's plug in negative 1. I'll help you. Negative 1, negative. Negative 1 is 1. What's 2 to the first minus 2? 0. All right, so then that tells me everything if you have anything going on about what exponents look like. And we should have known this anyway. No, we shouldn't. I'm a liar. 2 raised to a power should be increasing. But there's that negative is a y-axis reflection. Okay, now I know why this is happening, and now I know that this goes like this now. But just prove it. Plug in 1. I'll help you out, Jennifer. 2 to the negative first. Well, you tell me, what is 2 to the negative first? And then what's 1/2 minus 2? You can give me it as a decimal. Decimal might make more sense for us. All right, so it's negative 1.5, and that's why that makes more sense. Now we're starting to get that asymptotic behavior. We're getting closer and closer to this. Okay, I get it. I get it with the exponent. I'm sorry. I get it with the asymptote being there. Sorry, I couldn't grab the right word. And that's what our graph looks like. Okay, good. Enter. Who's next? Student number 22, Matt. This is what we did not do. This is what you're going to have to do on a test. What's the domain and what's the range? And then those limits. First of all, domain. You got it. And I'll convert that into this. And then what's the range? And then you're lucky, not that you're lucky, but I didn't ask bracket or parenthesis. I threw the parenthesis down already. It's a parenthesis because it never gets to negative 2. All right, and then as x goes to infinity, what do you get for y? Good. It's the asymptote approach. And then as x goes to negative infinity, what do you get for y? That one is x finger, y finger. If I move to the screen, as x gets negative and more negative, y starts taking off this way. For those that are missing those limits, we shouldn't be. These should be the questions that we do get once we have a picture. Okay, zooming in on this, I'm just going to keep going. And if you're getting nothing out of this, I don't know what to tell you. Student number 5, Jake. What do I plug in first? Jake. No. I want what makes this exponent 0. All right? You got your arm folded, not taking any notes. Negative 1. Killing me, Jake. All right? What's negative 1 plus 1? 0. What's 2 to the 0 power, Jake? What's 1 minus 3? Okay, and then where's the asymptote, Jake? So negative 1, negative 2. Where's the asymptote because of transformations? Right here. So y equals negative 3. Nine? That is Adam. Okay, what else do I plug in? Hint, hint. So it's right around these two. So what do I plug in also for x? 0 and what? Nope. Between -1. What two numbers has -1 in between them? Negative what? Can't hear you. -2. Okay, so 0 is easier. 0 plus 1 is 1. What's 2 to the first minus 3? What kind of one? People keep making these mistakes, and these are the mistakes that are crushing students in CAT. 2 minus 3 is a -1. All right, and then -2. I'll help you out on this. -2 plus 1 is -1. What's 2 to the negative first? What's 1/2 or 0.5 minus 3? That's negative, not 1.5, but 2.5. All right, so the ability to input, output, and think about those numbers. And then that proves that this is occurring. Okay, so all I have is a move left 1 and down 3. And that's where, thinking about the 0, 1 points, left 1, down 3. Okay, yep, same old, same old. But input, output also takes care of business there. All right, and then I'm gonna do one more because graphing needs to be like really solidified. Ah, Kathleen, if you're sitting at home watching this video, you got away with one there. 6. Oh, she left like in August. 19. Where are we at here? 20, 20. Ivo. Wait, is that 19? 17, 18, 19. No, Samantha, that's you. Okay, Samantha. Let's think about these transformations, and then I'll ask input output. What's the -3 do? We'll start with that. Which way does the graph move? To the right. What's the -5 do? And then what's the negative in front, just so we have an expectation of our picture? Okay, so we should expect something below the asymptote now. What is the asymptote? That'll help you with our input output. Okay, so she said flip over the x-axis, which was 100% correct. And then I said, hey, now have an expectation that the graph is down here. That's the flipping over the x-axis component. And your input output should really show that. Okay, now you know what it is, and I actually put this on. I put this on last hours. I put PEMDAS, and I should have done this at the beginning. Actually, no, I did it on our next step, but it really does apply here too. Okay, so one more question, Sam, and I think I'll leave you alone and make someone else do it. But what number should I plug in for x first? You are correct, and I'll make someone else do it now because you've done quite a bit there. Number 9, nice. That's a repeat. Adam. Okay, so here's what PEMDAS means. Here's how you do this, and I'm not going to write it down, but you plug in 3. 3 minus 3 is? You do this in order. This is multiply, that negative. You didn't finish your exponent. What's 2 to the 0? 1, and now it's negative. So that's what I'm worried about. So you get the exponent done by 2 to the 0, then you throw a negative on it. That's multiply. All right, so what's -2 minus 5? -2. I'm sorry, that's wrong. I said that wrong. -1, right? -1 minus 5 is what? My bad, dog. -6. I confused you. And then do it again, Adam. What are these two numbers that I'm going to plug in? That's how you got to do it. You seem confused on that before. You want to see what happens before and after the 0 power point. 1, 2, 3, comma, -6. That's my point. Oh, I'm on the other side of the asymptote, and that's proven now. There's the flipping over. Okay, and then last but not least, Adam did quite a bit. 14, that's new. 16, 15, 14. Maths, nice. Cover your nose. He knew that was coming. All right. PEMDAS. What's 4 minus 3? What's 2 to the first? 2 negative. You already said negative. Good. -2 minus 5. So it is -7. So you got to be careful. This evaluation, this is also where I'm kind of getting depressed, like the amount of students that can't evaluate. I'm talking about my math 2ers too. And those, when I said input, output for graphing, just make a chart of values and they can't do these simple evaluations. This does have a little trick in it. That's why I put PEMDAS off to the side. Anyway, blabbering. 2 minus 3 is -1. What's 2 to the negative first? Matt, what's 2 to the negative first? So it's -1/2 minus 5, which is what? Negative 5.5 is probably a much smarter way to write it so that you know that it's getting closer here. That was at 2. So I have this picture right there. Okay, so really hammering and doing this graphing. I'm going to rip on this book again. 3.1 does reference graphing, but their homework graphing questions are terrible. They're absolutely terrible. And that's why I did the worksheet yesterday and I'm doing this today. So I can't. I'm assigning out of the book, but they don't have any good graphing questions. So we'll just keep talking about it in class. Okay, but anyway, 14 again. Nice. Matt, what's the domain? What's the range? Don't get the domain. Did I ask domain and range in the last one? What am I doing? Matt, do this one, and then we'll get someone else for the other one. Get that for you in this format. And then what's range? Careful on this one. The order is important. Nicely done. Oh, I'm sorry. You did say it, but the mask and the whole thing. And then as x goes to infinity, careful on this one. Where's y go? You are correct. It goes down forever. And then as x goes to negative infinity, where does y approach? The asymptote. Oh, fine. I won't bother anyone. This last one, domain is the same. Range is negative 3 to infinity. Lost a student on that one. We have less students fifth hour anyway, so more people will get the answer questions here than fourth hour. And then x goes to infinity, so does y. X goes to negative infinity, it approaches that asymptote for the previous question. So know how to answer those as well. All right, so we have graphing. That was the first thing that we talked about yesterday. Maybe I flip-flopped it with you guys, don't care. Here's the next thing that we talked about, and here's my next student. Do we understand what we're doing when I do notes and can you do stuff? Kind of stuff. Student number 2 again, Jennifer. It's like your second time going, right? Again, the book is terrible. This does mean 2 raised to the 7 minus 3x. Book's not terrible, but their notational stuff should be better here when they type it. And then I'm just going to tell you how you do this, Jennifer. You got to change 1/4 to 2 to a power. What is that power? 2 to a power equals 1/4. See, what we got to do, and I'll let you think about it for a second, we got to rewrite the equation, but it's got to be still equal to the previous. So I got to change 1/4 to 2 to a power, but this must equal that. All right, and that's what some students mess up. And we're getting equal bases because what I taught you yesterday, which we'll move on. You got the answer? What is it? You are correct. It's 2 to the negative second, and I can't explain that anymore. You either know the rule or you don't. You either do it or you don't. You won't, right? And at this point, it's on you to figure that out. 1/2 squared is what 4 is, but now I got to get it to be 2 to a power. That's the negative exponent rule employed. And then what I told you yesterday was, if I have 2 to this equals 2 to that, the only way that could be true is if this equals that. Then I showed you some stupid little things, which I still think I erased them. I got rid of them. Oh, there they are. It's just like, we know that. I thought I had a sign over here. I think I got rid of all my other stuff. What's this hiding over here? I think that's another question. Don't worry about it. Okay, but anyway, it's grade school after this. Subtract 7. And then negative 3x equals negative 9. So x equals 3. So that's a nice little answer that some people might have been able to just figure out by plugging in. Wait till I get to the third one, all right? And you won't be able to figure out how to plug it in. This is CAT class. You need to know this little process here. I'm just getting rid of that because it's in the way. Yeah, student number 1. Yes, Mitchell. What's the common base that I'm going to use here? All right, and again, doesn't that look terrible? It very much, I'd almost argue that it looks more like 3 minus x than 3 raised to the negative x. So I did use the notation in the book. All right, so Mitchell, what's 1/81? 3 to what power? 3 to the negative 4 power. Because this is, I think what you were trying to say, or kind of like, you knew this was 1/3 to the 4th, and you kind of got that mixed up in your mouth there, right? Okay, so this is true. How did he know 3 to the 4th? What's 81? What times what? First thing you can think of. 9 and 9. And then what's each 9? 3 and 3. That's 4 threes. 9 times 9, 3 times 3. That's 4 threes. We should know that that is, I was doing fingers with this. These fingers represent 9s, and each finger represents a 3. 4 threes. Peace out. Okay, so then negative x equals -4, so x equals 4. That could have been figured out by plugging in, probably. Not the next one. So this is more in line what I would do on a test. I'm sorry, Mitchell. One came up again. If he thinks I'm lying, he can look at the video later. Maybe I'll do that. Okay, so I'll let you think about it for a second, and then now, Mitchell, sorry for the blues and the reds. I think it was 5 before, and then last year I changed it to 125. What's the common base? It is 5. Okay, and then that's what you got to do on this one. Figure out what is the common base. What would these have in common? What can I rewrite these as? And then what's 125? 5 to what power? Oh, that's too far. Did you say fifth? The third. Because what's 5 times 5? 25, and then times another 5. 5 quarters is 125 cents. So it's 5 to the third. So being numerate here, not freaking out over the math. And then what's you've done a few things. Let's try to get someone different. 16. Is that Gabby in the back? What is 1 over 25? Okay, then that's what I got to put in the parentheses. Very well done. 5 to the -2 raised to the x plus 2. So notice what I've done. I've done equal replacements. I don't know how else to say that because I just remember crazy things happening with students, how they misinterpret what to do here. These are equivalent replacements, so nothing's been changed. But what has been changed now is the ability to drop the 5s. Before I do that, Gabby, what am I supposed to do with those exponents? Distribute, which means multiply. I was expecting multiply, but you're right. Distribute is a better word. Or what we should say is multiply, so therefore I distribute. Not that you're wrong or I'm wrong. Really kind of combining the two things there. And then drop the 5s. It's because the rule 5 to this power equals 5 to that, only if this equals that. All right, and then add 2x to both sides. I really shouldn't have to show this in this high-level math class, but I do have some students struggling with basic solving skills. Oh, that's sometimes I get crabby. I do. I was crabby yesterday. Bloop. That one you can't figure out just by looking at it and plugging in. All right, so that's why the algebra always wins. The algebra always is able to, this process is always able to get us our answers, and that's what we're exercising. All right. Okay, so that is nothing new as our second bell rang. Here's the new stuff, and I may have a couple more of those in the homework. I think I do. The very last question. The very last question is not a I even put it on I always love it when there's 2 multiple choice questions, and then there's a question that says do all of A through D, and then someone puts 63D. They just circle D. No, you're supposed to do all 4 of those. Wasn't a multiple choice here. But anyway, speaking out loud, here's our third concept for section 8.1. 3.1. Just simple evaluating. All right, and I do these and I love these, and I'd put them on a no calculator little scenario. I will literally take your calculator away. You will have 0, not even a borrowed one. Actually, what this employs is, do you know what you're doing with your exponents? Do you know how to evaluate? Do you know what they mean over and over and over again? So this isn't a graph, it's an evaluate, and it gets an exact value. And look at the question says without a calculator. So evaluate without a calculator. Just make that as simple as possible. Computes they use. Okay, and then I don't have to ask this person this, whoever gets picked next. This is what you do. You, of course, substitute. Gabby, right? You can see in the video if you think I'm lying. You just got picked again. But you replace x with -3. What's 2 to the... Okay, so again, this is what I told my students last hour. This is PEMDAS. What's P stand for? What's E stand for? Exponents. What's M and D stand for? And then I said that together, just like the student last hour. Do you clump these together as a step? What are you doing? I had to wake up somebody. All right, and then you clump the A and the D, the A and the S together. Okay, so Gabby, what do I do first? The exponent. Okay, we'll get that over with. What's 2 to the negative third? There you go. You don't take 4 times 2. If you take 4 times 2, you're a PEMDAS violator. All right, you didn't do the exponent first before you multiplied, and I get that all the time. And those things shouldn't happen. You know why they do happen? The calculators. You guys have not written math down enough back in your grade school rules or years, I mean. All right, and then what's 4 times 1 over 8? Last hour couldn't get this. Did you hear what she said? Okay, so you take 4 times 1 over 1 times 8, and you get 4 over 8. And then what's 4 over 8 reduced to? 1/2. You got that right away, didn't you? I know, gotcha. Gotcha. Ooh, I was hoping you get picked here. Ivo! Another absence. At least it's not a test. 9. Adam! This has got to be the last time you go. I mean, you've been picked 3 times already. Boom Shaka Lockers. Oh, Adam almost fainted. Just like Evan apparently did. You made the video. Cover your nose. Thank you. Maybe it came off your nose when you fell asleep. Okay, I'm waiting until okay, so you at least know that this is what's happening. And then at least know PEMDAS. I got to take care of the 9 to the negative 3 halves first. What does 9 to the negative 3 halves become? That's switched. Flipped. So that becomes 1 over 9 to the 3 halves. You got it. Now watch how I write it. Don't panic on this. That does mean the same thing. It does mean I am dividing by that 9 raised to the 3 halves now. So that's what a negative exponent means. Don't get crazy about the fractional exponents. This is exactly the same if I just had 2 to the negative second, which we've already talked about this about 7 times today. If you walk out of here not knowing what a negative exponent is, it's because you're sleeping, you fainted, you don't have your nose covered. It's all 3 of those things. Ah! Okay? 1 over 2 squared. Okay? That's what we said all the time. So don't do anything crazy with the fractional exponent. The whole thing moves, the whole exponent becomes positive. All right. Now the next thing. Adam, I felt like you've went enough. Student number 3, Kathleen. All right. Student number 10, Noah. What does 3 halves power mean? Let's start with this. What's the 2 mean? Oh, you remember in August, I went through this. We actually did this in August, and then cover your nose, please. And then and it was the fractional exponents, and part of why people were like, what's going on with this class? And they were going all waving their arms in the air as they walked out of here. It has to do with radicals. So I'm going to give you a 50-50. There's going to be a root on this. Is this the index or the power? Like, does it mean square root of 9, or am I squaring 9? Now you got a 50-50. Pick the other one. Square rooting. So now that I went through this, hopefully you remember this now. And now it's your job to know this. We're coming back from chapter PR, the very first day in August or second that we taught something. We actually went through this because it's a review concept. And I'm allowed to say that, all right? That this means square root. Therefore, Noah, what does the 3 mean? Exponent or radical? Exponent. So this means this. What's the square root of 9? What's 3 cubed? So you do know your numbers. You just had to know that that's what that means. This is why it's no calculator. It's the only way you're going to learn that this is what this means, so you know what's behind the scenes. By the way, what's 3 over 27? 1 over 9. 3 goes into 27 9 times. Okay, step three or three things. Your first homework questions, I think 8 and 10, deal with evaluate. See that? 7 through 10. I made up a couple and then I assigned 8 and 10 for you. Then the last thing is this, number 4. And I did say the story as some people wrote this down. This is a little different than graphing. The way we can graph our exponentials, the way we'll do it without a calculator is by the shifting thing. You know, the shifted format, left, right shifts, up, down shifts, flipping over an X or Y axis. This is not that at all. In fact, this format of an exponential equation has nothing to do with that. I was kind of thinking about that when I was comparing graphing with this concept here. This is a more real world. What happens in the real world for exponential scenarios? Like at the end of this chapter, we're going to spend one whole day on how to be a millionaire and actually be financially responsible in some way, shape, or form. In the future, you're going to be buying a house, a car. Some people may have already bought a car. Anyone buy a car in here and have to pay the payments? Okay, well, you guys are all lucky. Unless you just don't have a car. But if mom and dad, parent or guardian bought you one like I did, or my spoiled kids, it's got a sweet, brand new 2002 Ford Focus that barely runs. That's what my daughter got. All right, anyway, I'm a teacher. I got no money. So here's what the standard thing is, and this is what I was talking about like exponential growth. You'd have an initial value, A, and then times b raised to the x. B is whether this increases or decreases. I put a little thing here. I think I had an idea from the past that I need to erase there that I threw in there. It's like investing. I think invest $100 at 10% after 1 year. Be 100 times 1.1. We'll talk about that more tomorrow. So B is the base. We'll talk more about this base tomorrow as I finish off these notes here that I know I have to get going. So this is more of a real world exponential scenarios. Money growing, population growing, or decaying. Some towns the population decays. I'm going to jump right to this question. And then you homework doers, you actually need to get this written down. You need to get this answer written down. Because you need this answer for your homework question 53. The answer to this question is used to answer 53. So I love the signals of those that just don't take notes. I just love it. I know you're seniors and you have the right to do that, but just don't complain. Don't have the parents call. Don't do it. Already, the sort of dog. I met a student today during Compass and said a couple things about maybe this isn't the class for you, but you make that decision as we finish off. Then I got a mean email here in 10 minutes. So it was like I thought I was doing a good thing, making sure that you're comfortable. So I just don't like the game anymore. It's driving me crazy, this lack of doing your part, but then complaining about your situation. Not going to do it. Okay, so look at the question. And I gave you a chance as I was complaining there again, using the table data. This is at the bottom of your page, wherever your homework is. And assuming the growth is exponential, stop! Soon as you see that, you access this general form. Okay, I got a real world exponential scenario, some initial value times some base raised to the unknown power. But I'm going to change it. And the only reason I'm going to change it is because I want it to mirror like some variables. So why would I change it to this? It's not a big deal. What do you think P stands for? If you looked at this, what is this all about? Population. What's P of T? Population over or as a function of time equals. What do you think P sub 0 is? Starts with an I, IN, INI. Initial population. And then times some B raised to the X. I didn't change anything. I just wanted you to be aware sometimes I just change the letters to make it emulate the situation. Okay, Columbus. And then notice what it says. When would it surpass 800,000? Well, first of all, we need to find the exponential growth thing. So we need to find an equation. Okay, so here's Columbus. Here's how we trick ourselves. And this is how we can do this so that we have a basis to answer this question. Here's the 1990 population. Here's Columbus. Don't write this down, or at least write the chart value down. But don't write this next thing here. Really, what this is the coordinate 1990 comma population. So it really is that x comma y. Input 1990, I should output 632,910. Make your life easy though. Make this year 0. And now you know what you tricked yourself to? This is now the anyone? Initial population. So let me ask you, what would 1980 be? What year would that be? It's okay. What would 1980 be? -10. You're correct. It'd be 10 years in the past. So therefore, what is 2000's population? 10. Okay, now you got it. Now you got what you need to get the equation for this. So what you should be able to do is right off the bat put P of t equals, now that I made this 0 comma, the initial population is 632,910. You really should be able to do that. Last hour, I plugged in 632 for this side in 0 for this. By the way, what's b to the 0, everyone? 1. So I end up getting that the initial population is 632. So therefore, it belongs there. Then what do? You take your second point, your second data point, and you plug it in. This is how you solve for b. Because then you could get over a 10-year process, what is my growth rate, or what is my b value? We'll talk about what I mean about growth rate in a second. So look at what I did here. Plugged in 711 over here, the population over 10 years, and then 10 for x. 10 years, x is, I should have put, actually, you're right, Mr. Samulus. That shouldn't see b raised to the x. It should be b raised to the t, the time. Made a mistake there on that equation. Never caught that over the years. Nice. Good catch right now. Cool. Okay, now I got to focus on this. How in the heck do I solve for that? Well, first thing is, what do I do with this? Everyone said subtract. I almost fainted there. What operation's being done there? What's the opposite of multiplication? All right, so don't do that again. But I do get that a lot. I'm glad you said that, so hopefully we can exercise that bad math out of your brain. Think about your opposite operations. Opposite of times is divide. Okay, now I gotta, this is gonna be tough. How do I solve for this? And I'll just write this down and then you go ahead and punch it on your calculator. How do I solve for b to the 10th? What do I do to both sides? What's the opposite of b to the 10th? Okay, what's the opposite of b squared? Square rooting. So what's the opposite of b to the 10th? 10th rooting is the way to say it. And then I guess I should show you where that's at on your calculator. Or if you know anything about fractional exponents, you could raise that to the 1/10th power. That's actually true. All right, but for purposes of time, and I'm actually doing better than last hour. I must have, I had some food incidents last hour. Some students were making a picnic last hour, and I had to squash that immediately. Took someone's apple right out of their hand and stepped on it. It's great. Someone had some cookies, and I threw them in the heater back there. So anyway, here's those are lies. Here's the X root button right here. There it is. I knew it. See it? So when you access that, which I don't know where I'm at here, if I'm on the main screen, and then you put 10 there, and there's the 10th root of that fraction. So that's how you evaluate that. And that's all I care to show you. Okay? You can take care of it from there. All right. Now, remember what we were finding. When will this population surpass 800,000? Here's what you should have got if you went ahead and did this. You should have got 1.0117. Notice how far I went. I went 4 decimal places because our population is quite large. And if I stopped at 1.01, that's significantly different than 1.0117 when you're dealing with so many people. It's so less accurate. That's why science teachers do those sig figs and all that. I think it's appropriate to go 4 decimal places when you're in the hundreds of thousands of people, because it does really matter and make a difference. So what this is now is the growth equation for Columbus. And I know it's growth because this B value is greater than 1. And we're going to talk about that tomorrow. We're really going to focus on these kind of questions only. I might still do some graphing in Bellwork because graphing every day. I don't know why graphing is just such a hard thing for the students, but we'll do that. And then, but here's what you do on this. Boom. Oh, the boom. Okay, what you do is go to Y2 and put 800,000, because this is going to be an exponential growth thing. And as this rises, the Y's are the population. I want to know when it makes it to 800,000. So I want a horizontal line crossing that graph. And then what am I going to find between these two graphs? What do you think I'm going to find? The what? What is that for these two graphs? The what? Intersection. And I shouldn't have to show you that. We've done that a lot this year. I do have this though. You want to manipulate your window. I mean, for the love of dog, you're putting Y2 equals 800,000. Your Y maximum should be above 800,000. I just put it at 1,000,000. So those are my window values that I choose. And how many years might this take? This might take 30 years or less. You might want to put 50 years. That's why 0 to 30 is a good check for our X window. And where I'm talking that should be is when you type these in Y1, Y2, you go to your window, and these are the things that you change. 0 to 30, might as well do it in this thing. And then actually for the Y window, 0 to well above 800,000. You don't want 800,000 right at the edge. You want to go above it. And then when you press graph, those two things in Y1, Y2, you see where they intersect. And then what you do on that next is hit second and then intersect after you put them in Y1, Y2. So without showing you all that we've done earlier, that is a good description of what you do on that to get your answer. Okay? All right. I'm going to shut her down.